Today I'm very happy. We have Sofia, Dr. Sofia Perez-Guzman from Georgia Tech, coming to tell us a little bit about her work on automation and application for trucking and delivery robots. Sofia has a PhD in transportation engineering, a master's in economics and industrial engineering from RPI, and a bachelor's in industrial engineering from University of Valle. Sofia's interests are in transportation, sustainability, food chains, and food deserts, and uses methods such as optimization, econometrics, spatial modeling. So I'm very happy you're here crossing the country from Georgia Tech, and we're all yours for the next hour and a few minutes. Thank you.
Thank you very much. Good afternoon, everyone, and I hope that you can hear me well. My voice is not working great today, but I'm gonna do my best. If I start coughing, I apologize. I might have to step out for a minute or two, but I hope it all goes well. It only needs to work for 1 hour, so all the best. Thank you for the introduction and thank you for the invitation. So today I'm gonna talk about, as Professor Haller said, some of the research that I've been doing related to autonomous trucks and sidewalk delivery robots from the perspective of acceptance from the consumers, acceptance from the road users, and what does this tell us about the future of implementing these technologies. But before this, I of course needed to tell you a little bit more about my research. My research is more broad than what I'm going to speak about today, and I brought this slide that kind of summarizes everything. I just realized there's something that might prevent you from looking at that corner, but my research overall is about designing freight transportation solutions that consider the social aspect of freight transportation, that either consider the negative externalities that freight transportation poses in our society, but that also considers that maybe freight can offer some solutions to complex social problems. And the way I explain this a little bit further is with the three main research thrusts that I'm working on. The first of them, which is related to disaster response logistics. So I'm interested in developing tools that helps us better move goods in the aftermath of an extreme weather event. And I'm interested in making these decision support tools more humanitarian, more accounting for human behavior. So there's that mix of moving goods, but also the social aspect of it. Plus, it is related to a very complex problem. So freight transportation plays a role in improving a little bit this problem. The second one is food systems logistics. And in this area, I'm interested in increasing food accessibility of fresh food to vulnerable communities and using freight transportation solutions for doing this. And one of the problems I've been working on in this area is related to food deserts. And what I have found with my research is that we have been trying for so long to bring people closer to the food. Why don't we switch that to bring food closer to people? And we do have the food. There's a little bit of a mismatch between the supply and demand, where things are produced, where things are needed. But I believe we can bring food closer to people, and we can design different types of logistics and freight transportation solutions to do so. So that's the second thrust. And then the third thrust is urban freight transportation. So I'm generally interested in designing urban freight systems that are more sustainable, more energy efficient, more environmentally friendly, and more recently, how can we use emerging technologies to do so? So the talk today is definitely related to that third thrust. And I included there a couple more points: community-led resilience and freight data integration, which are some of the newer things I'm working on, which are also related to these different thrusts. And I also wanted to just do a big shout out to my students, which are the ones who allow all of this research to be possible. And this is why I enjoy doing this work. So why not just throw a picture that I took last semester with that? So for the first part of the talk, I want to show you The research that was conducted is a paper that is right now under review. And we looked at the adoption of sidewalk delivery robots for food and groceries deliveries. And this was done in conjunction with my collaborators, Dr. Trilce Encarnacion and Dr. Juliana Arellano. And this is what gives the start to the rest of the research that I'm going to talk about today. So first, why these robots, and we call them SADR, why SADR, and why the consumer perspective, which is the focus of this research? Well, we find that the robots give some operational efficiencies to doing deliveries in urban settings. They definitely, because they're electric, they definitely provide an opportunity for doing positive environmental impacts. And what has been found so far in the literature is that we can use this technology relatively well for delivering small packages, for delivering packages such as food deliveries or groceries deliveries. And why did we want to focus on consumer adoption specifically? Well, because if we want to implement this technology, and we have seen it already implemented in several campuses, at least here in the US, if we want to implement it more broadly or scale it, we would need to understand consumer acceptance, consumer willingness to adopt the technology. What are the factors that are going to influence people wanting to choose to get a delivery with this type of technology as opposed to using the alternative? So that's one of our motivations to deciding to choose to focus on the consumer acceptance side of this research. And then why do we want to focus on e-commerce and last mile delivery? Because there are several challenges that we're aware of. And we all know that in the last 10 to 20 years, there's an increase in e-commerce. So a lot of traffic of commercial vehicles in our cities, creating a lot of congestion, lack of parking spaces. This, of course, has generated an increased interest in developing last mile delivery solutions, and the robots, the SADR actually come as a solution for this problematic. So what we found in the literature related to this was that there is a lot of success stories using robots in industrial and service sectors. So in industrial, all of the robotic related to for instance, construction or manufacturing. Also the service robots that, for instance, interact with other people, for instance, service robots that operate with elderly populations. There has been a lot of research related to that, a lot of success implementing these types of robotics. We also found that there's general consumer reservations regarding this technology. People are worried about the safety of interacting with the technology. People are worried about their privacy, the privacy of their data, their privacy, the privacy of the whatever function they are doing with the given robot. And then, of course, everything related to automation, people are worried about job displacement because of the robots. There is a lot of research related to the factors that influence the use of all of this kind of robotics technologies. There isn't really much related to the factors influencing acceptance or adoption of SADRs, right? And what are SADRs? I forgot to mention this at the beginning. The SADRs are the robots that go on the streets and that are doing deliveries. A very specific type of robot technology. There isn't much done with these types of robots yet regarding the factors that influence their acceptance. And what we found is that what has been done has been only looking at the social demographic factors, whether people who are younger or older, whether income or education play a role in using these robots. But what we were wondering with this study is, do the operational features of the robot play a role? Are people thinking about, well, if I'm making a delivery and I'm provided with an option of choosing a robot, if I'm going to pay more, which one I'm going to use? So is the cost of the delivery going to influence? Is the time the delivery takes to get done going to influence? And that's what sparked our idea and the gap that we found in the literature. So we, after crafting this idea a little bit, we went ahead and did an in-depth interview with an expert from KiwiBot, who had implemented the service, the delivery service with a robot in University campus in New Mexico. And we received very interesting feedback. First of all, it was very, and this was back in 2022, the technology was it was highly automated back then, not as automated as Starship. There were several barriers of entry for the shippers to participate in this. And they were reaching populations that did not use any delivery services before. And this is very relevant to some of the research that I'm doing currently. The most interesting part that we learned from the interview is that they found, because it was implemented in a university campus, that the visual appearance of the robot was key, that all of the students were very attracted to using them, or at least trying them out for the first time because they look cute, because they look nice. And they were just overall attracted to the robot being, having a pretty face, which is interesting because the KiwiBot robot actually has a face, as opposed to some of the other companies that don't look as cute or as nice as this one. So with that, we decided we wanted to focus on looking at how do the operational features of the service using SADR impact the willingness or the intention to use of the robot, and what would we need then to make this a relevant service and to make it successful, to scale it a little broader. And we went ahead and investigated this under the assumption that we could evaluate the adoption of this technology using a model that is called the technology acceptance model, which has been established from a long time before. So this is the technology acceptance model, the framework that we use to assess the research questions in our research. Under the technology acceptance model, there's basically three main constructs or hypotheses. So under this model, we say that perceived usefulness of a given technology and perceived ease of use of that technology jointly influence the attitude towards using the technology, and that attitude impacts the behavioral intention to use and eventually the actual use of the system. And under this framework, there is room for adding additional variables, but the main idea underneath is that it is perceived usefulness and perceived ease of use what drives the use of that technology. So we adapted this framework to our case of the Sidewalk delivery robots. In our case, the perceived usefulness, and let me see, I don't have it here. Okay, these are the definitions below are definitions from the actual framework. So what we did was the perceived usefulness would be the degree to which a person would believe that using a Sidewalk delivery robot would make their life more efficient. The perceived ease of use would be the degree to which a person would believe that the using a delivery robot would be easy. And then the intention to use would be the probability that the person would choose to use a delivery robot over using an alternative. We, however, believe that there were additional factors that would be influencing that intention to use delivery robots. And we included these three additional constructs in our conceptual model. These come from the literature. We did not invent them. And as a matter of fact, the first two, perceived risk and privacy concerns, have been widely used in technology acceptance models and other type of technology another type of acceptance models for similar technologies like Sidewalk autonomous delivery robots. They have been used for autonomous vehicles, for service robots, and other types of autonomous technology. However, what we found is no one else in the research of sidewalk delivery robots has used any of these additional constructs. So we looked at perceived risks as the possibility of the delivery or the robot or the package being damaged as the delivering or the environment around it being compromised during the delivery process using the robot. And we defined the privacy concerns as the possibility of losing control of any information related to the delivery if I use a robot. And then we included this third one, perceived visual attractiveness, which is the closest we could find to this idea of the visual appeal of the robot actually influences intention to use. And this perceived visual attractiveness is also a construct that has been used in the past, not for autonomous technologies, but for other types of technology, like for evaluating the visual attractiveness of a website and how that influences the use of that website. So we borrowed that concept and we defined it as the degree to which a person believes that the SADRs and their use are appealing. So with that, we also defined a couple of additional factors that we wanted to check their effect on influencing adoption or acceptance of this technology. And we looked at the delivery time, the commodity type, and the cost. So for delivery time, our hypothesis is that the longer the delivery takes using the robot with respect to the delivery time of the alternative, that is going to diminish the willingness to use this type of technology. For commodity type, what we argue is that, well, first of all, that robots are currently being used for certain types of commodities only, but that people may have different willingness to use the robot depending on what type of commodity is being transported. So we wanted to see if different types of commodities would influence people differently. And then cost. If the cost of using the robot, I don't know what happened. If the cost of using the robot is higher than the cost of the alternative, then that of course is going to diminish the willingness to use this technology and make it less attractive. So we proposed this framework. We have the technology acceptance part on the left. We have the behavioral intention to use, and then we have the delivery features also influencing that behavioral intention to use. And we wanted to measure the utility that people perceive from using this alternative and the actual choice that they make. So how did we conduct this study? We did a survey. We did a first screening survey where we were looking for participants, where we're looking for people that live in urban or suburban areas and who have never used this technology before. So we wanted to focus only on people that did not have previous experience, partly because part of the previous research related to technology acceptance model shows that when people does have experience with that technology, the results of the model are going to be very different. So we wanted to focus on people that did not have any experience. We collected over 1,000 valid responses, the people that matched the population that we were looking for. We invited them to the full survey, and then we obtained a total of a little less than 300 responses. I think I'm failing. I think I did not update these numbers because we did run another survey and to complement this, and the numbers were higher than this, and we obtained over 600 responses, and I forgot to update this. What did we ask in the survey? There were a set of attitudinal questions regarding all of these constructs that I showed you, which is how do people feel about these different constructs, and we use a Likert scale to assess those attitudes. And then we had another component, which is choice scenarios for stated preference on their choices, where we presented the respondents with multiple scenarios where we would vary the operational features of the robots and the delivery, and then we would ask respondents to choose whether they would prefer to have that specific delivery be made with a robot or be made under a traditional delivery mode. And then, of course, we included social demographic questions. For the experimental design of the choice scenarios, we had an orthogonal two-block experiment design. We had 3 attributes in our experiment design. We had a flat, for delivery price, we had a flat rate, and we had a percentage of the order value. So 2 different types of pricing mechanisms that people would choose from. And for delivery times, we had 1 attribute that was just the delivery time in minutes. And for each of these attributes, we had 2 levels. We had a total of 12 scenarios. And as I said, where people were given with the option of a scenario of a delivery, what would they choose, varying these different attributes. We also tested for the effect of commodity. Commodity was just a separate question. So we have 6 out of these 12 scenarios were for groceries, and 6 out of the other 6 were for prepared food. These are some of the results that we obtained, just statistical analysis on the attitudinal indicators. And for instance, what we found here is for the indicators related to behavioral intention to use, we observed that, for instance, around 7% of the people strongly agree that they will use SADR or will recommend others to use. Around 40% would either agree or strongly agree with that. When we look at if people are willing to pay more to receive an SADR delivery, we found that half of the respondents did strongly disagree, 80% strongly disagree or disagree. So people are not willing. People say that they are willing to use this type of technology, but they are not willing to pay more to use it. When we look at the results of perceived ease of use and perceived usefulness, and without getting into a lot of details, overall what we found is that people agree or strongly agree that using SADRs would increase or would be easy to use, but they're not, they don't agree or disagree as much that they would be useful in their daily lives or that they would make their lives more efficient. From the indicators of perceived usefulness, for instance, we found that the robot saving them time was the indicator that showed the highest agreement among all of the indicators of perceived usefulness. For the other indicators, perceived risk, visual attractiveness, and privacy concerns, we found that privacy concerns are not as high as perceived risk. SADRs are more perceived as risky than people being concerned or if their privacy if they're using them. What was interesting was the results regarding visual attractiveness, and it was mixed if we look at the results indicator by indicator. But for instance, around 60% of the people agree or strongly agree that SADRs would be fun to use and that they are cool. We did not find the same result with making them look cool or looking cool in the sidewalk, but in aggregate, we did find that people agree or strongly agree that there is some perceived visual attractiveness to this technology. So with this, yes.
I have a quick question. Because you said, and maybe I misunderstand, you said that you screen out everyone that had experience with it.
Yes.
But these are questions that they're supposed to know something about it, if they looks cool and so on. So they have seen them on the street, but they were not using them as consumers, or?
No, we briefly introduce what a sidewalk delivery robot is in the survey. We show a picture and we explain a sidewalk delivery robot is a device that goes on the sidewalk and makes a delivery. We show the picture. They might have seen them on the street and we did not control for that. We only control for the fact that they had not used it before.
Yeah, so these reactions are based on your explanation of what.
Yes,
Yeah.
or they had previously seen them, yes.
Thanks.
So with that, what we did was that we implemented a hybrid discrete choice model, which has in one part a mimic model, multiple indicators, multiple cost model that matches this indicators with latent variables that are part of an structural equation model. to test the effect of all of these factors that we argue will impact behavioral intention to use. And then in the other part of the model, we have the discrete choice model that has the effect of all of the operational factors and how they influence the actual choice in the scenario aspect of our study. And we're able to run all of this together and eventually find the influence of the attitudes and the actual choices into the utility. And there are a lot of numbers here, and they are very tiny, and people who are in the back, I'm sure you cannot see them, but I want to bring your attention to the main results that we found, which is the effect of the main constructs into the behavioral intention to use. We found that perceived use has the highest effect in behavioral intention to use from all of the factors that we tested. So people identifying the robots being easy to use is what has the highest impact in them being having intention to use it. For the perceived usefulness and ease of use, so from the components of the technology acceptance model. And we also found that perceived risk, of course, has a negative influence in the behavioral intention to use. The higher the perceived risk of the individual, then the lower the intention to use, and the same with privacy concerns. And similar to what I mentioned before from the descriptive statistics, privacy concerns has a very small effect compared to perceived risk. What was the most interesting about this is perceived visual attractiveness, which actually had a very high influence in the intention to use of the robots. Which we were prone to believe that this was going to happen from our interview, but finding it in the data was very impressive. From the results that we obtained regarding the operational features, what we found is that when people actually chose between getting deliveries using a robot or getting their traditional mode, people are more prone to their traditional mode. So when actually choosing, most people prefer to stay under most scenarios with a traditional mode of delivery. We also found that the cost has a negative increased cost, it decreases the probability of choosing robots. Increasing the delivery time also decreases the probability. Something that was interesting from these three factors was that fixed rate is the one that has the highest effect. So in terms of setting up a cost structure for the robots, if we choose to impose a fixed rate, that is going to decrease the likelihood of customers choosing this technology as opposed to choosing a variable rate. We also found that there is a significantly higher probability of using the robots for prepared food than for grocery deliveries. As I mentioned, we had the hypothesis that it would vary by commodity type, and we did find evidence for that. And we also found that in urban settings, people are also more likely to choose to use the robots than in suburban settings, which also makes a lot of sense. We did analysis of elasticities and cross-elasticities, varying the operational features of the robots. And for this, we basically found that demand is generally inelastic to varying cost and delivery times, but traditional deliveries are going to be more sensitive to the performance of the robot. So when we look at the elasticity, when we change the performance and pricing of the robot, the traditional delivery is going to be more affected than the other way around. If we change the performance or the cost of the traditional delivery, that's still not necessarily going to mean people are going to switch to using the robot. So that was also very interesting. We also found that the absolute direct elasticity is also higher for the traditional than for the sidewalk delivery robot. So overall, we found a low rate of substitution between these two. And so just to conclude this part of the study, we found that definitely the design of the robot and also that the interface that is used to interact with it is going to heavily influence the willingness to use this technology. Even though we're not very hopeful that given the alternative of a traditional mode of delivery, people are not necessarily going to switch to the robot. Even though it seems very appealing, people have reasons to choose it. they will still choose the alternative, the traditional alternative delivery. So we also found that perceived usefulness is going to be a crucial determinant of, I think I have a mistake here. It should be perceived ease of use. It's going to be the most crucial determinant of intention to adopt. And people expect that the delivery, that is going to be easy to use this type of technology. And overall, this should be considered if any service providers want to implement this type of technology to make sure that they are implemented successfully. So after this study, we were thinking about what other factors could possibly influence the adoption of this technology, and more importantly, what can we do about actually making this a feasible solution to implement, right? How can we make it operationally attractive for the service providers? So this is further work that I've been doing, mostly with with some of my students at Georgia Tech, but I continued advancing this with my colleagues in Encarnacion. And what we have been thinking is about, can there be any cognitive biases that are driving the decisions that people are, or the factors that are influencing people choosing this, people choosing or wanting to adopt this type of technology? And so we have been looking at status quo and risk aversion, status quo being the tendency to prefer whatever I'm currently using, and risk aversion being the avoidance or minimization of an uncertainty. And what we are hypothesizing is, well, maybe one of the reasons why people are not really choosing to use this technology might be influenced by any of these two type of cognitive biases. And what we found in the literature was that there has been some research in the technology acceptance model literature that has considered this type of biases or the influence of these biases. But for applied to other technologies, there's definitely no research related to robots or to robot-like type of technology that look into the effect of these biases in the adoption of the technology. So what we're working on now, this is research that is ongoing, is that we want to know if any of these cognitive biases influence acceptance of SATR, and our hypothesis is that an increased status quo or increased risk aversion is going to pose greater resistance to being willing to adopt this type of technology. And what we want to do, we haven't gotten so far yet, is that we want to continue to explore structural equation modeling or discrete choice modeling. The reason why we're continuing to pursue this avenue is because with the survey that we collected, we did collect a couple of variables related to these cognitive biases. So we want to go back to our data and see if we do find some evidence of these biases playing a role. And I have some preliminary results here. We have run some factor analysis where we have found that both status quo and risk aversion do have a negative effect on behavioral intention to use. However, what we have continued to find as we have tried to run all sorts of statistical models to our data is that this effect seems to be pretty low, at least pretty low compared to the other factors that we did have and that we did measure. So our next steps is to continue quantifying and continue to search for any evidence of the biases playing a role. We want to try to see if there's any moderating effect of these biases to some of our other factors. And we want to also model the effect of those biases in choice, since we have focused so far in the behavioral intention to use and not in the choice yet. We have looked into the choice data and the biases responses, but we still haven't found any evidence of a strong effect there. So then we were wondering, what about the businesses? So far, we have been looking at the consumer side. And what was interesting, the reason why we started to look into that, I'll tell you that in a moment. Let me pause there. I want to acknowledge one of my PhD students who has been strongly leading this part of the business side of this research. And we went ahead and looked into the literature, and we found that For sidewalk autonomous delivery robots, or even for using autonomous technology for deliveries, there's very little that we have looked into the role of the businesses and how these technologies may be impacting the businesses, or what factors are going to make this technology operationally feasible from the business perspective. And what we are wondering, or the gap that we found in the literature, was that we really don't know how SATR could influence businesses' operations. And if once they're starting to use them, they will continue using them. And one of the reasons why we got really interested in this is that we actually got the robots at Georgia Tech starting in the fall of 2024. And this is the service area of Georgia Tech. This is Georgia Tech campus. And we have a little bit of a service area outside of campus, which is the part of the campus that is on the Midtown area, which is Tech Square, and then also a little bit outside of campus, which is where we have some dorms for the graduate students. But we started to see the robots around starting in August 2024, and we got interested in how are these businesses working with these robots? Is this a model that is making sense for them or not? Something that is interesting about this is, so at Georgia Tech, we have a service area of 450 acres, a total of 50 robots that are servicing this area. But also, we didn't have any delivery service before on campus for the restaurants that were on campus. So if anyone wanted to get anything from one of the campus restaurants, they had to go there. There wasn't any delivery app working. And this actually touches back with the feedback that we received from our in-depth interview that said that these robots were actually working pretty well in places where there wasn't any delivery service before. Another thing that is interesting is that even though these businesses did not have any delivery options before, and now they're using the robots, people on campus still get deliveries from other businesses outside of campus with traditional delivery apps. But in this area of Tech Square, which is off campus and in the Midtown area, the businesses that are here that are using the robots, they are also using other delivery apps. So it's a very interesting ecosystem for us to explore and to figure out how is it that these businesses have been impacted, how is the system working with them, and are they going to continue using? Or maybe some of the other businesses, some of the other restaurants that are around that are not in the service area, what would they need to be able to be interested in this type of system? So in our next step, what we want to do, and this is still, the design is still under construction. We're interested in doing in-depth interviews with the business managers on campus. There are many of them. It's 20 restaurants that are participating that are working with the robots right now. And we want to know how their system has changed. So we want to understand their operations, how they have adapted their operations. Do they see any benefit of using the robots? Do they not see any benefit? Is it increasing their costs or not? And for the adjacent businesses, are they interested in this, in participating in this system? What would they need to be interested, or how much would they pay to be interested? So this is research that is in progress. I would love to get some of your ideas related to this, or any of what I have talked about so far when we finish. That is one part of the research. I don't know how long do we have. Yeah, we still have some time.
Do I have some questions now or at the end?
We can have some question, even though methodology wise is very related, but
Okay.
if anyone has a pressing question, we could take it now. Yes.
Is kind of the expectation that these robots are sharing sidewalks with people? So is there any look at like land use or changing sidewalk use or even interactions with individuals on sidewalks?
We haven't considered anything related to the interaction of the people with the robot. We're purely interested in people wanting to use them or not. As a matter of fact, the person who's receiving a delivery via robot The only interaction the person is gonna have is when the robot arrives. So studying, for instance, human robot interaction on the sidewalks would be a completely different type of study, yes. Yes.
Well, I have just a question about, in terms of its general acceptance, but how do you go about, ensuring that the, robots are generally accepted by non-human organisms like fauna? Like dogs, cats, they're gonna walk past those two, and dogs, they'll get scared at those. I don't know if they will, but and also cats, they might become interested or start knocking on it. And or those are just like the smaller animals, what if like it passes by a horse or a goat or something like that?
Yes, we, as I said, since we're not studying that human robot interaction directly in our model, we do not capture that. However, we do capture the effect of, let me put it back. We do capture the effect of perceived risk in people wanting to use it, in people choosing them to get the delivery. And one of the indicators that we have for that perceived risk is the risk that the robot poses in the environment around it. So we do have one of the indicators that says that I believe that the robot might harm people or anything in the environment around it, which could capture a bit what you're suggesting. So in that case would be capturing if people believe that the robot is gonna harm others or animals or any other kind of road user, then that would influence my selection or my willingness to use the technology. That is how far we could get. Yes,
Sorry.
one more and then we continue. Yes?
You mentioned that there is no interaction between human and robots, but did you consider interaction between robots in your model? For example, they communicate this together, and I think when there are a lot of robots in one area, they can communicate this together and share information. But my question is, how you find the importance of this shared information? For example, what is the most important information that robots need to communicate this together?
Yeah, we definitely do not have that in our study. That is out of our scope, since we're looking at the factors that would influence a person choosing to use the technology. That could also fall, if we wanted to still look at the effect of the communication between robots in people choosing to use the technology, that could also fall in the perceived risk category in that construct. We did not include it though, but it could be one indicator that we could ask. And it would be if people think that they're, well, not in the perceived risk, but in the privacy concern, if people believe that their privacy could be at risk from robots communicating with one another. But what you're describing would fall very out of scope of this work. Okay, I will continue to talk about the other study that I wanted to show today. And Miguel, if you can please remind me how much more time do I have?
Like 20 minutes.
20 minutes, perfect. So after Dr. Encarnacion and I started our research with the robots, we later thought it would be cool to also do research with autonomous trucks, because why not? So we wanted to look at a little bit of a different perspective of this technology, and we were interested in the other road users. So once we have autonomous trucks on our highways, what are the other road users going to, how are the other road users going to feel about this technology? And how is that acceptance of the existence of the technology going to influence the support for regulations that limit the use of this, that limit the possibility of implementing autonomous trucks on our highways, on our transportation system? So we were intrigued by that. And as I said, this was also work that I was doing with my colleague, Dr. Encarnacion. And why did we want to look at autonomous trucking technology and why the acceptance? Well, we do know that this type of technology poses some benefits and potentials. It could increase efficiency of our logistics systems, lower some of the costs, and be more sustainable. It could eventually lead to long-term economic and operational benefits to our overall freight transportation system. However, there are some concerns and barriers that are very clear, and as a matter of fact, for some of the research that we're currently doing, we did look at some law here in California that was precisely limiting the size of the autonomous trucks that could be on the highways. There are concerns, safety, trust, regulatory concerns. These are not particular to trucking technology, but in general to automated vehicle technology. There is a lot of uncertainty about the regulations and how we could implement them. So we wanted to continue with the idea of acceptance because of these reasons. And what we found in the literature was that, again, there's a long history of implementing technology acceptance models with autonomous vehicles. There is some research on autonomous trucks. However, the research that has been done on autonomous trucks and acceptance of autonomous trucks has been from the perspective of the truck driver, not from the perspective of the rest of the road users. So we found that there was a gap, and that there could be a lot of potential on exploring the user's perspective of this technology, and in particular of understanding how that perspective influences support for regulation of the technology. So what influences this acceptance that we've been talking about, especially for autonomous trucking? So some public concerns related to how unpredictable can be the technology. I mean, these are way larger vehicles than any of the other kinds of vehicles that we have on our roads. There are increased safety risks and trust issues in the safety. We also have the aspect that from crash data and safety analysis, a high percentage of the accidents are actually with trucks. So what is going to happen when these trucks become autonomous? There's the regulatory aspect, which I also mentioned. So there are some proposed safety regulations, such as maybe we just restrict this technology to be on dedicated lanes or on specific areas, or be restricted to not circulate in certain areas like school zones. And from the public acceptance of the regulation, there are a lot of mixed opinions. There are a lot of mixed opinions on whether people want this on our roads or not. They are perceived as being as improving. They are perceived as improving safety, but at the same time, we don't trust the technology enough to believe that safety will be improved. And when we compare this with the AD perceptions, autonomous technologies are facing even greater skepticism than regular autonomous vehicles. So we were looking again at different types of constructs to be able to model the factors that influence this existence acceptance. And for this case, we were looking at these main 4 constructs: technology, experience, and we argued that the depth and experience and breadth of experience that people have interacted with previous autonomous technology before may make them accept the technology further. And what is previous technology? For instance, advanced driving assistance systems. If you have already used your car to do a little bit of self-parking or any of the other driving assistance systems, that may influence how you accept the technology. The perceived benefits, the fact that maybe you accept, maybe you believe that it's going to make the logistics system more efficient, or it's going to improve the operations, or maybe it's going to lead to reduce cost of the goods that you're buying. So if you believe that there's a perceived benefit from implementing this technology, then we argue then you would positively accept the technology. However, if there are perceived threats that you identify, such as anything related to safety that we've discussed before, that would negatively impact your acceptance of the technology. And then we have another interesting construct, which is the affective response. So we argue that any kind of emotional reaction that you as an individual may have towards the technology will also influence the acceptance. What is an emotional reaction? Excitement. Maybe you are excited about technology, about autonomous technology, and that might positively influence. Or maybe you get anxious about it and that might negatively influence. We define existence as acceptance of technology as the comfort that a person may have being around this technology, not being the primary user, but just being around it. And we have the regulatory preferences. So how much would you endorse implementing regulations to have more robust control of the technology? Meaning that you would want to see the technology less. So we argue that if you do have a strong support, if you do have a strong existence acceptance of the technology, you would have a lower regulatory preference. So we put all of those hypotheses in this conceptual model. We again conducted a survey. In this one, we were looking for people, we did first a screening survey where we were looking for car owners and people that had not driven trucks in the past. And from this, we obtained almost 1,000 valid observations. And this survey only contained the part of attitudinal questions, assessing how people feel and with a Likert scale of indicators regarding all of the constructs that I previously mentioned. These are some of the results that we obtained, and these are the statistics for the regulatory preferences. We had 6 different regulations. We used 6 different regulations. One where we say autonomous trucks, and I forgot to mention, we are also considering autonomous truck platooning. So autonomous trucking technology are allowed on highway only, or allowed on dedicated lanes, or we implement some sort of area restriction, or allowed at night, or there's a human required in the truck, or if it's a platooning, human required in all trucks. And we found that in general, people have a strong agreement with all of these restrictions at various levels. The one that has the highest support is implementing area restrictions for both technologies, autonomous trucks and autonomous truck platooning. And we run a structural equation model for both technologies separately, for autonomous trucks and for autonomous truck platooning. These are the results. Here I did not include all of the results from our models. I mainly included the entire model for you to look at the relationships that we found that were significant. And what I wanted to highlight from here is that we did find that technology experience has a positive impact in existence acceptance. Perceived benefits also has a positive impact. The impact of perceived benefits is actually the largest of the positive impacts on existence acceptance. So even though technology experience has a positive impact, the impact is lower than perceived benefits. Perceived threats has a negative impact on existence acceptance, and its impact is actually larger than the benefits. So the fact that people feel threatened by the technology, that might completely take on the effect of perceiving that the technology has some benefit. And what was also interesting was that we did find a lot of evidence of the effective response having an effect. And we found that 3 indicators about excitement have a positive effect on existence acceptance, but also that anxiety specifically. From the negative effective responses that we tested, anxiety had a negative effect, which is significantly large. And it has a negative effect that also, it's an interaction with the perceived threats, and eventually it's a moderator through perceived threats as well of existence acceptance. And we also found that if people accept the existence of this technology, then they would have a lower regulation support for it. We found similar results with different, slightly higher effects for autonomous truck platooning. And just to summarize some of the key findings from this study, road users are cautious about the technology, but they are open to it. They definitely identify that there are benefits from it, but they are more concerned about the risks than they are interested in the benefits. For autonomous trucks and autonomous truck platooning, The highest level of support is for implementing area restrictions. And the highest level of threat perception is related to higher probability of crashes with pedestrians. We also found, and I did not mention this, a couple of socioeconomic effects. Elderly and women are more likely to support stronger regulations, and people who are familiar with ADAS are less inclined to support food regulation. So what does this tell us? A couple of policy-related insights that, for instance, there's definitely a lot of room for supporting some regulations than other, and that would already lead to a higher support of the technology. That we need to emphasize further what are the economic advantages of using this technology, and that might overcome the threats. And we might also need to clarify that maybe the threats are being overstated, or that there might be some benefits that are not being captured, or that are not being captured by those threats, so that we can increase that acceptance of the technology. And definitely some sort of targeted communications that look at the different social demographic groups and how different populations perceive this technology. We want to continue implementing it. After we did this study, we were wondering, well, how can we actually get to influence people to accept the technology? And so what we decided is a study we're working on at the moment, which is ongoing, which is in collaboration with colleagues from the School of Psychology at Georgia Tech. And we are conducting a driving simulation study where we are testing the framework, and where we want to look at what is the effect of the information that we provide people about the system. What is the effect of driving alongside, on a simulated environment, but driving alongside the technology on people accepting the technology? And can we do some changes into their support of the regulation? So that's the study that is currently ongoing. What we envision is that with this additional study, we're actually going to be able to provide more actionable strategies for policymaking and for implementing the technology. And I did want to show you a little bit of the details of the study. So for this study, we have, our key question is, how do the information framing, the information we give to people about the technology, and the experience driving with alongside autonomous technology, how can it change existence, acceptance, and support for regulation? And for this, we are using multiple strategies. For the question related to exposure of the technology, we will use a pre-post survey, pre-simulator, post-simulator, and we will be measuring things such as trust, acceptance ratings, and regulatory support. We will be looking at how does the behavior and the psychology responses change. So we will be measuring physiological reactions of people to see if there's indeed any changes in behavior when people are driving alongside this type of technology, to see if indeed their affective responses, which we did find an effect in our survey, to see if indeed physiologically there is a change in the affective response. And that will measure during the driving simulator. And we will be measuring the information framing impact. We will be providing different groups of participants with different type of information about the technology. We will have a control group, one group that only receives information about the benefits of the technology to enhance that effect, and one group that receives information about the regulatory support, and we will be measuring the effect of that information in their acceptance, both through the behavioral aspect of the study and then differences in the survey. And this is a little bit of the explanation that I just gave. We will be doing between subject manipulation, so playing with the information that we give to each of the subjects, and then within subject manipulation with different driving exposure to different types of vehicles. And at the bottom we have a schematic overview of the experimental procedure. People will pass a screening test, again, to make sure that they don't have, for instance, that they know how to drive and they don't have any experience driving a truck. They will then conduct an entry survey. They will be exposed to the information. They will do the driving simulation, and they will conduct an extensive survey. And we included here a couple additional details of the various data that we are collecting at each of these steps. And overall, as I said, some of the data will be survey data related to the attitudes, same attitudes that we already measured in our conceptual study with the survey. And some of the other data will be related to the physiological data of the individuals. We will collect driving behavior as well. And for the physiological data, heart rate, GSR, and RME. And we are in the process in which we have designed the experimental procedure. We have finally, after several months, obtained IR research that can be presented soon. For the study that I mentioned before with Dr. Encarnacion, that is also a paper that is under revision as of now. Hopefully will be published soon and you can all take a look at it. So what we hope with this is that we're actually able to, and I realized after this slide that this also applies to the sidewalk delivery robot research. We want to make sure that we're able to understand context-specific acceptance, that we're able to track attitudes changes over time. And I'm particularly interested in this at Georgia Tech now that we have the robots and to look at the effect of after people have interacted with the robots, are they more willing to use them or not? Is it going to change over time? Are people going to get tired of them because maybe they don't work as well and they go back to whatever they were doing before? Definitely trying to bridge between the public and policy perspectives, trying to get into what insights do we need to provide to make both of these solutions scalable, and working on the public communication for both of them. If they are indeed beneficial for our urban or regional freight systems, then what do we need to tell people to make sure that they are implemented? And looking at some sort of integration. And we were talking about this a little earlier. What if your robot is used in interaction with another mode? What do you need to do in those cases? In the case of the trucks, what if the trucks are also used in interaction with other modes at some point? So what do we need to do in those cases? So with that, I end my presentation and thank you all for your attention. I'm happy to take any questions you may have. Thank you.
Questions?
In your survey with the consumers, was there any question regarding like whether they use delivery services to begin with? Like, is there any stratification of like delivery users versus just like who will never use delivery?
For the robots, right?
Yes.
Yes, we did include that in our screening survey. Now I'm not sure if we included that in the full survey and if we controlled for that. I would need to take a look at it again, but we did look into it, at least in the screening survey. That is a good point. I believe that it might definitely influence people's choices. Thank you. Yes.
I have two questions. So one is, in one of your slides, I think the introductory slide about the first study, you mentioned that there are operational efficiencies for last mile deliveries associated with these robots. What's the kind of measure that you're talking about there in terms of the efficiency? And in the case of Georgia Tech, you said there wasn't any delivery from the restaurants and things on the campus until that point. So would these robots be like hoping to replace people taking their car to the restaurants, or is it going to be like replacing travel by people on foot or by bike?
Good point. So to your initial question, that is a good observation. What we were thinking about, and we did have data to support that claim, was the idea of a very, very congested city where if you're using a truck for doing last mile deliveries, it is a very hard task to to complete, while if you're doing an alternative such as a robot, it would be operationally more efficient. I hope that answers your question, but if not, we can chat about it more offline. To your second question, which is very interesting. The robots are currently replacing people walking to the restaurants. Our campus is large, but not large enough for people to drive. I don't believe it would make sense to be driving to some of the restaurants unless you are in, like, on the west side of campus and go to Midtown. But still, I feel like people still travel. Some of the trips, maybe a few of them, may be via the internal bus system, the bus system of the campus. Several of them scooter and bike trips as well. Yes.
And then also for the two studies, you had a screening survey. And then you showed a survey questionnaire related to the actual research question to a subset of people, like based on whether they have experience with something or not. So did you account for this kind of sample selection using like a two-stage model? Where you can first model any factors that might be associated with whether they actually have that experience in the first place and whether they've been filtered out, and then use that in the next stage where you're actually investigating your research of interest, because it can bias the results of the outcome model.
Yes, that is a good point. We did not account for that. We implemented, all of our models were implemented only on the second set of surveillance. Yes, we did not account for that. We did have strong justification for doing that that selection of our population target, but we did not account for that in our modeling process. You're suggesting. Yes.
Great presentation. Many good questions, but so your track studies, the question is general population perceived or preference about policies. Have you thought about doing the same study on the robots? Because that's a very important question. What people want to see on the street, not if they want to use it or not. So take the second study and redo it for the first one.
Yes, that is a good point. We haven't thought about that. With my colleague in psychology who were doing the tracking one, she's actually very interested in the human-robot interaction now that we have the robots on campus. She's actually very interested in that aspect. I don't believe she has mentioned anything about the policy side, but that is such a great idea.
It's almost like taking it as is and see what people would like to see as a policy related to these robots on campus. Or
yes.
And the second one is kind of a follow-up on this question. From my many years of experience of doing stated preference, I always screen out the people who don't have an experience. We have no experience with the topic, and only keep the people that do have experience with the topic, because from my experience, these people that only thought about this thing, the first time they start to set an opinion about the question was when they were reading the survey. It's very hard to then predict what they will do in real life. So why not to take everyone you screen out and also survey them? What was the cost of survey everyone?
Yes, I see your point. Definitely possible, and what we could do would be just to control for
in the model.
if a person has experience or not.
Survey them all and then model them differently.
Yes, our reason for doing that screening out process was just based on our literature on the technology acceptance model that did show that people who had experience with the technology would behave very differently from people who did not. But I agree with you, that could definitely be controlled within the model. Thank you. Yes. Yes.
How does the cost of for the consumer, how does the cost of a delivery robot compare to the cost of just a person delivering it through a delivery service?
We use the same cost levels for both. So we took the prices from a regular delivery and assumed that for the robot, it would be the same, right? And then we would have a higher level. So in some combinations, we would have both at the same price or at the same cost, and then in some other combinations, we would have one higher cost, one lower cost, and vice versa.
Okay, and when they were the same cost, did people like prefer one method or the other?
Yes, the traditional one,
Okay.
yes. Under all other conditions being equal, people chose the traditional over the robot. Yes.
I have a question related with the delivery device. How is the interaction of that equipment and the person who receives the delivery? It's like reading passing a passcode or something like that, or reading a QR or something?
Yeah, so the person has the app installed in their phone. They order through the app. They don't order through the, for instance, restaurant's app. They order through the robot app on their phone, and they get the information about where the delivery is. And once it has arrived, through the same app, they go to the robot and they scan a code, and then it opens.
Did you consider like that type of interaction in like in the survey, if that can improve like the use of the service or something like that? Because sometimes people just doesn't like to interact with other people, so it's better if receive like the delivery like by a robot and maybe using some in the package. That's it.
We didn't consider that, but some of the papers that we read that had done similar studies during COVID found that it was a factor, it was a very influential factor of deciding to use of adoption of the robots. During COVID, people didn't want to see other people, so it highly influenced, that lack of contact of other people highly influenced their adoption. We didn't consider that. Yes. Yes.
Sorry. For example, between human and robot interactions, it's possible to, for example, in some cases, we want to return our food, with robots to the restaurant because the order is wrong. Did your model consider this, that for example, we put the food or goods in the robots and return them in the to restaurant, or their planning is just for businesses? Is it possible that human order and plan the robots?
That is a good question. I need to step out for a second. I'll be back. I told you this was gonna happen. I'm sorry. I'm glad this happened at the end. We did not consider that in the study. However, part of what we want to understand with the study that we're doing with the businesses now, from the business perspective, is that we want to take a look at how is that working out, because that is something that we know about. Because we haven't done the survey yet, we actually don't know, but it is something that we are considering that could definitely happen. And as of now, I actually don't know, for instance, if it would be something that the app manages or that it has the feature to fit to solving, or how would a business do that?
From the perspective of a non-user of this service, right, I can envision that if this reduces delivery costs, there would be many robots around the Davis campus, and they would be taking up, or they'd be reducing capacity in our pedestrian and bicycle ways. And so I was wondering if you surveyed people's annoyance from that perspective, and you saw that as a possible source of flowback.
It was more or less what I was wanting to do.
Because like I
Yes.
run around campus, and it would be really annoying if I was dodging a million robots. That would
Yes.
Kick them hard enough.
It's the same question for cargo bikes.
Yes.
It'd be bad for the phone too.
It is interesting because the survey that we did to the robots was to the, from the perspective of the one who's using it to receive a delivery, not even thinking about, for instance, I do wonder what results would we get if we repeat the exact same survey, but with the Georgia Tech community. Yes. It is different. What you're thinking, I think it would fall more under the other study that we did with the autonomous trucks, which would be the existence acceptance. Or like all of the other users, all of the other road or infrastructure users that are not necessarily, that have anything to do with the robot, but that are still affected. Or maybe even some of the, for instance, Georgia Tech community that are both users of the infrastructure and may get annoyed with it, and then get the chance of using them, and maybe they decide to not use them because they're just annoyed by their existence. So that, yeah, definitely very, very interesting things that we could test out.
It's always a good result, more research is needed.
Yes. Yes. What is interesting is that we don't have that many robots. It's 50 robots, it seems, it's 50 robots for 20 stores. At times we see them all parked, and the campus is big enough that we never actually see them in a situation that seems stressful or annoying.
Only in the advertisements from the company.
Most likely, yes.
Yeah. Good.
Well, thank you so much.
Thank you all.